Today's session we are going to see nucleophilic substitution reactions, okay, for SN1 and SN2 mechanism. So before that we will be studying a small concept, okay, for every reactions, the reactions react to give products, okay. So this reactant, it contains two main things, that is substrate plus reagent, okay. So what is reagent? Reagent is the substance, which is the substance go and attack, okay. So the reagent, it may be electrophile and it may be nucleophile, okay. So electrophile means electron deficient species, nucleophile means this is a electron rich species, okay. So it may be a pair of electron donor, okay, and it may be negative charge and neutral molecule, okay. For example, for nucleophile, OH minus, Cn minus, H2O, this O contains a pair of electron, okay. So all the electron rich species, okay. So what is the role for this nucleophile? This nucleophile go and attack the substrate. So substrate one which is being attacked by reagent, okay. So that is called substrate, okay. So these two, substrate plus reagent, it produced intermediate product, okay. So the first of all we cannot get the whole products, first of all we can get the intermediate product. The intermediate product would be, that is carbocation or carbanion or carbon free radical in the transition state, okay. So that is transition state means that is not a product, okay. This is a one intermediate form, okay. Right after this intermediate, it gives the product, okay. So this is each and every reactions takes place such the substrate plus reagent, it gives the intermediate, after intermediate it gives the product, okay. So here after that we are going to see the types of solvents, okay. So these types of solvents, it is a better understanding for the SN1, SN2 mechanisms, okay. So here there are two types of solvents, one is polar solvents, another one is non-polar solvents. So what do you mean non-polar solvents? Non-polar solvents means that is non-polar, that all the hydrocarbons, this is an example for non-polar, there is no dipole interactions here, that is, and also there is no electronegativity difference between these two carbon, so that is non-polar, okay. The N-hexane and cyclohexane, benzene is a type of non-polar solvents. Polar solvents again classified into polar protic solvent and polar aprotic solvents. So polar protic solvents which is produced H plus ions, okay. For example, water, alcohol and acetic acid, okay. So this is produced easily dissolved with water, it produces H plus ions, okay. So aprotic solvents means it won't be produce any H plus ions. For example, that is acetone, and this C double bond O, instead of the same two dimethyl, we can introduce S double bond O, that is dimethyl sulfoxide. Simply we can say DMSO, okay. At the same time, this dimethyl, that N, C double bond O, CH3, this is dimethyl acetone, okay. So these are the kinds of aprotic solvents, okay. So here if you find any polar protic solvents and polar aprotic solvents, so we are going to see next then mechanism for SN1 and SN2. So these solvents may used, okay. So in which type of mechanisms takes place in polar protic solvents and polar aprotic solvents. So see here, this is the general part, that is, this is alkyl halide, okay. So this alkyl halide we may consider that is substrate, okay. So the substrate, this substrate, and here this nucleophile is a reagent, okay. So reagent means that is electron rich species, okay. For SN1, SN2 mechanisms, that is the nucleophile electron rich species, that is very important, okay. So this is alkyl halide the nucleophile react the alkyl halide. So what's happening here? Usually these two pair of electrons present. Okay, if it is this presence of halogen atom, if gets these two pair of electron from this carbon, what's happening? It gets partially negative charge, this gets partially positive charge. Okay, so that time this reagent go and attack this alkyl halide or react with alkyl halide. This is a best leaving group, easily it gets the leave outside, so X minus. Okay, so this nucleophile come and approach the carbocation. Okay, so this is the general format for nucleophilic substitution reactions. Here so the basic substitution reactions takes place. Okay, one thing attack and so another thing is leave out. Okay, this is nucleophilic substitution reactions. Okay, next mechanism, SN1 mechanism. This N for nucleophilic substitution reactions in unimolecular. Okay, so that is unimolecular nucleophilic substitution reactions. Okay, right. So suppose this carbon, it contains 4 different groups. Okay, right. இப்போ இந்த கார்பன் வந்து இப்போ 4 different groups இருக்கு. Suppose weak nucleophile come and attack this carbon. Okay, so it cannot attack straightly. இப்போ என்ன செய்யும் அப்படின்னா, இப்போ நியூக்ளியோஃபைல் வந்து ரொம்ப வீக்காக இருக்கும்போது அது வந்து it cannot attack the direct way. Okay, அப்போ until it is waiting for here the alkyl halide, the pair of electrons is present here. So this halogen is highly negative, so attracts a pair of electron towards itself, so it attains a negative charge. Okay, so here this halogen is a best leaving group. அதனால இது the nucleophile வந்து இங்கே இந்த கார்பனை வந்து அட்டாக் பண்ணும்போது இந்த ஹாலஜன்ஸ் வந்து என்ன செஞ்சுது, லீவ் ஆகிடுது. ஓகே, ஸோ இட் இஸ் அ ஃபஸ்ட் ஸ்லோ ஸ்டெப், ரேட் டிட்டர்மினிங் ஸ்டெப், ஸ்லோ ஸ்டெப், பிகாஸ் ஆஃப் த நியூக்ளியோஃபைல் இஸ் அ வீக்கர் ஒன். ஓகே, so the halogen leave out. Okay, after that this carbon, it gets positively charged, that is the intermediate of carbocation. Okay, so first வந்து tetrahedral sp3 hybridized இருக்கு, the attached to the halogen atom. After it gets partial negative charge and it's a leaving group, it left. Then this carbon, it gets a positive, the partially positive charge. Okay, electron deficient. This carbocation is a sp2 trigonal planar. Okay, right. So now the weaker nucleophile, it is 2 possibilities: go and attack front side as well as the go and attack this carbon to the carbocation to the back side. இப்போ 2 possibilities இருக்கு. இந்த nucleophile வந்து front side attackum பண்ணுது, back side attackum possibilities இருக்கு. Okay, so we can get new product. Okay, so for if it may the nucleophile attack the front side, this structure, this product we can get. The same time nucleophile attack the back side to the carbon, we can get another one product. Okay, so there are 2 products. Suppose these 2 products, we are going to apply the plane polarized light towards these molecules. What happening? So one molecule plane polarized light towards the right hand side, another molecule the plane polarized light towards its left hand side. Okay, clockwise and anti-clockwise. So that is D plus and DL minus. The net result, it gets cancelled. 50% of D plus and 50% of L minus, that is DL mixture, that is called enantiomer. So that is called racemic mixture. Upon SN1 reactions வந்து என்னது, it undergoes racemization or it produce racemic mixture. This is one key point. Okay, because of plane polarized light towards the right hand side and plane polarized light towards its left hand side. Okay, right, that is racemic mixture. Okay, here it undergoes 2-step process, SN1, but it undergoes 2-step process because of this order. It is a 1. So this order we cannot change because this experimentally calculated value. Molecularity means how much reactant react to produce the product. Here it is the molecularity means 1 because only 1 the reactant. So the rate proportional to this concentration of alkyl halide. Okay, first it undergoes a slow step because of after until wait for the formation of carbocation, that is rate determining step. After the nucleophilic attack to the nucleophile attack the deficient carbon, we can get the product. Okay, this is for SN1 reaction. Okay, next one, SN2 reactions. SN2 reactions, suppose the same carbon contains 4 different groups. Here before that we studied the weak nucleophile. Suppose it may be a strong nucleophile, so this strong nucleophile go and attack this backside carbon, backside attack to this carbon, it forms through this weaker bond for the carbon. Okay, இந்த nucleophile வந்து இப்போ ஸ்ட்ராங்கராக இருந்துச்சு அப்படின்னா இந்த கார்பனோட வந்து என்னது ஒரு வீக் பாண்ட் ஃபார்மேஷன்ஸ் ஆகுது, அதுதான் வந்து nucleophile and carbon with this 4 different groups. Okay, so this is before that sp3 tetrahedral. At the intermediate the transition state, so it is a sp2 because of this is a weaker bond, we cannot consider that. After it is a highly negative, it gets a negative charge, so it leave outside. Okay, இது ஈஸியா லீவிங் குரூப்பா இருக்கனால வெளியில போயிடும். So this nucleophile attack this the strong nucleophile attack through this carbon, the inversions takes place. Inversion அப்படின்னா we can get like this a product. Inversion means suppose இப்போ அம்பர்லாவை நம்ம வந்து என்னது அம்பர்லா இப்படி கொண்டு போயிட்டு இருக்கிறோம், அந்த அம்பர்லா வந்து சப்போஸ் இப்போ ரொம்ப விண்ட் வந்து பயங்கர ஃபோர்ஸாக இருக்கும்போது அது இன்வர்ஷன், அதாவது அதோட இது இன்வெர்ட் ஆப்போசிட் சைடில் வந்து என்ன செஞ்சிருது, திரும்பிக்கிறது. ஸோ அந்த இது தான் இங்கே சரியா. ஏன் அப்படின்னோன்னா பிகாஸ் ஆஃப் திஸ் ஸ்ட்ராங் நியூக்ளியோஃபைல் அட்டாக் திஸ் carbocation. Okay, so inversions, Walden inversions, this is called Walden inversions. For SN1 the racemic mixtures or racemizations takes place, here the Walden inversions takes place. Okay, so the overall sum up we can conclude that is the trick box. Suppose for alkyl halide, for SN1 reactions, tertiary carbocation form the favors the reactive order of reactivity favors. Okay, for first tertiary, then secondary, then primary. Before that sometimes in case benzylic or allylic present means that also the higher reactivity for SN1 reactions, because of that is it undergoes a racemic structure. Okay, here only for the tertiary carbocation is favors the SN1 reaction mechanism. Okay, after for suppose SN2 means the primary carbocation of more stable after than secondary carbocation after than tertiary carbocation. Okay, so nature of solvent for SN1 reactions, if you find any polar protic solvent, so that particular the reactions it undergoes only for SN1 reactions. So what are the polar protic solvents we studied? Water, alcohol and acetic acid. So sometimes the AgNO3 also. Okay, so SN2 means polar aprotic solvents. If suppose the arrow mark present polar aprotic solvents like DMSO, DMF, dimethyl formanamide and acetone. Okay, acetone is a SN2 polar aprotic solvent. Suppose this acetone mixed with water, it undergoes SN1 polar protic solvents. Okay, so that also you keep it in your mind. Okay, so next nature of nucleophile. For SN1 that is a weak nucleophile, so that only we can get 2 types of product that is the racemic mixtures. So for SN1 strong nucleophile it attack fastly, so the inversions takes place. Okay, so that is a strong nucleophile. Okay, suppose Y for tertiary for SN1, for primary for SN2, it's a stable carbocation because of for here the nucleophile this is easily cleaved. Okay, so the tertiary carbocation after this secondary, because of why it is a tertiary, because of this carbon bonded with 3 other carbons, so tertiary carbocation. This carbon bonded with 2 other carbons, so it's a secondary carbocation. This carbon, only one carbon, it bonded with only one carbon, so it is a primary cation, primary carbocation. Okay, right. So for SN2 not favor for tertiary because of, so suppose nucleophile வந்து இது attack பண்ண வந்துச்சு அப்படினோன்னா இங்க 3 bulkier groups இருக்கு. ஓகே, ஸ்டெரிக் ஹிண்ட்ரன்ஸ். ஸோ இதை இது பண்ணி இதால் வந்து என்ன செய்ய முடியாது, இந்த ஸ்ட்ராங்காக இந்த கார்போகேட்டையனை போய் என்ன பண்ண முடியாது, அட்டாக் பண்ண முடியாது. ஸோ டெர்ஷரி இங்கே ஃபெயிலியர் ஆயிடுது. ஸோ விச் ஒன் இஸ் அ ஃபேவர் ஃபார் SN2 ரியாக்ஷன்? பிரைமரி. ஸோ தேர் இஸ் நோ ஸ்டெரிக் ஹிண்ட்ரன்ஸ், ஒன்லி ஒன் alkyl group is present. So directly this nucleophile attack that. Okay, so this is a difference for SN1 and SN2. Okay.